So I have downloaded this particular Juniper OVF file. Okay, it is 5.13 GB. So it's the same one. How much size of your file? So the Ospf, why is Ospf needed? How Ospf works and lab. So Ospf is, open shortest path first, and it's a internal routing protocol (IGP), and it's a open standard RFC 2328, and it's a link state routing protocol designed for IP networks. So this is a very short introductions about the Ospf, how the Ospf is gonna working. So you open shortest path first, it means that it will gonna be check it out the shortest path to reach the destination. Once we're talking about some internal IGP protocol, it's internal communications within your autonomous systems. So suppose you have an organization and you have 200 number of routers. So you are going to use this particular routing protocol Ospf version 2. And it's an open standard. The RFC 2328 is there, and it's a link state routing protocol. So link state routing protocol it means that there are several links will become connectivity will be happened and designed for IP networks. Okay, this is going to be used for the IP networks. Why is Ospf needed? The second question is in front of you. So the matter of fact that if you're talking about the open standards protocol, okay, anybody can use it. It's a link state protocol. Okay, different links will be communicating with each other. One router, second, third, fourth, whatever router it will. So the number of routers. Once the routers are more in numbers, then you allocate your areas. So area 0 is a backbone area. Then it is used for the scalability. It is going to do fast convergence, supports authentication and security. Mobile supports VLSM, variable length subnet masking. It's going to be support IP version 6 is Ospf version 3, and support load balancing, consuming low bandwidth and uses a hierarchical structure. So these are some features, the characteristics of the Ospf. Why are we going to use the Ospf? Very common things I'm talking about here. Then we're talking about some Ospf, how the Ospf is going to working. So it uses a link state logic, neighbor discovery, topology, database exchange, and route computation. So it divides routers into areas for route optimization and segmentations. So neighbor discovery, topology, database exchanges, and route computations. These are the three state logic things need to be done into the routers. Okay, and this is second, how it's going to work. It divides routers into areas for route optimization and segmentations. So route optimizations, how your routing things gonna working, and how it is going to be segment your networks. So it's very basic things like what is Ospf and then how Ospf works. So neighbor discovery, topology, database exchange, and route computations. So once any troubleshooting, you will have to find out the three things. Wait a second. हाँ भाई. Hello, Oscar, are you there? Your voice is not audible. Am I audible right now? Mm, am I audible? Okay, perfect, perfect. That's okay. Then we're just talking about some neighbor discovery. Okay. So I'm just going to be asking the question that OSPF works and how the neighbor discovery, how the things gonna working on the neighbor discovery. So neighbor discovery is each router discovers its neighbor's router sending hello messages. So every second, okay, the hello message is going to be sending to a different routers, so that they will going to check it out whether the availability, the link is up or not. If your neighbor routers is not going to responding, then it says that your peer is dead. So the router from adjacencies with its neighbors. So neighbor adjacency requirement is interfaces in the same subnet. So what is requirement? It is requirement the interfaces are in the same subnet. Source and destinations things. Different router ID between neighbors. Routers in the same area. Same authentication parameters. So the same authentication parameters, router, same area, and interfaces in the same subnet. And our router, different router ID, different between different neighbors. So this is the adjacencies requirement for any neighbors. So topology database exchange. So topology database exchange is each router generates its own network topology information LSAs messages. So each router floods its LSAs message to its neighbors. So each LSA's copy on the internal Ospf topology database LSDB, and each router has the same LSDB. So the matter of fact that Oscar, you need to be understand here is the OSPF, how the OSPF is gonna working. So OSPF is gonna working on the three things like the database tables, database exchanges between the two different routers, the topology tables, and routing information exchanges. So in the databases exchanges, each Each router generates its own network topology information, LSA's messages. So yesterday we have checked it out the different type of LSAs. It's going to be messages will be happen LSA1, LSA2, LSA3, LSA7. So each router floods its LSA's message to its neighbors, and each router stores a LSA's copy on its internal Ospf topology database LSDB. Each router has the same LDSB. So link state advertisement message information is router ID of the SLA LSA. So list of the router interfaces, IP addresses, subnet and mask. So what happened? We required some router interfaces to be connectivity. We required some IP addresses, the prefixes. We required some subnet and mask. List of routers, reachables, neighbors to each interfaces. So once you going to run a command, show CDB neighbor details. So this link state advertisement comes to the picture. The topology table exchange databases, they will going to provide information about your neighbors. What are the prefixes? What are the IP addresses? What are the router IDs? So all sort of information is very mandatory once you're going for troubleshooting in the Ospf environment. Then link state advertisement is LS link state H options, LS type link state ID advertising routers, LS sequence numbers, LS checksum and length. So the matter of fact that you need to understand the link state advertisement, how it's going to working, and how it's going to be communicate with the different neighbors. Then we have route computation. So route computation means that each router analyzes its topology database and executes shortest path first SPF algorithm. So route summarizations, route computations. How it's going to do the route computations? So computation. So each router analyzes its topology database and executes shortest path first algorithm. So router chooses the shortest path route to each destination from its respective SPF tree. The router generates entries in the routing table for those selected destinations. So the matter of fact that if you're talking about the route competition, so first of all, it is going to create a topology, analyze the topology databases, and then it's going to execute the shortest path first. Routers choose shortest path best route to each destination from its respective SPF tree. SPF tree is before run SPF and after run SPF. SPF is like a shortest path first. So if we're talking about into the before SPF, the different connectivity will be there. But after done SPF shortest path first, so it will going to check it out which is the right path to going to destinations. So all the different type of path is going to be removed, and it will take the right path, the shortest path to path first to what going to communicate. So we can say that OSPF is a shortest path first. It is going to run on the three tables: topology tables, database table, and routing tables. And it's the backbone area is 0, single home environment, and if you have a different areas, if we have the number of routers are increased. So communication between the OSPF routers, how they are going to be communicated is very simple thing is over there. OSPF packets encapsulated in the packets, IP protocols, 89 standard 24-byte header, OSPF packet type, field OSPF router ID of sender, packets checksum, authentication fields, OSPF area ID, uses multicast IP address 224.0.0.5 for all the OSPF routers. And designated routers use multicast IP address is 224.0.0.6. So designated routers multicast IP address are different, and multicast IP address for OSPF routers, all other routers are different. So somebody will going to ask you the question that what is the designated routers uses the multicast IP address. So you can say 224.0.0.6, and all the other routers are going to use which path? So they are going to use 224.0.0.5. So it maintains neighbor relationships, elastics, design router DR in multi-access networks. The hello packets. Hello packet will be sent out every 10 seconds. So the hello packet is going to maintain the neighbor relationships, and it is also elects design routers for multi-access networks. So hello packets is going to be communicate within the two different neighbors, the routers, to check it out that this is the link is active or not. So it is going to send out every 10 seconds. And if the router is not going to responding within the 40 seconds, default 40 seconds, then it says that yes, this router is dead. So default is 40 seconds, and we're going to be increase and decrease as per our requirement. And there is a network masks there, list of neighbors will be there, ensure that the link is bidirectional. So link can be, it is, we can say that the link is going to be bidirectional, different sites. Then the hello packet, if you just take a look into this particular routers is going to sending the packets to the different routers, and every 10 seconds the hello packet will be sending to the different routers. These routers are required in the same subnet. The router IDs should be different. They are in the same topology. Their area is required the same one. This is the conditions required. So suppose this is the router is going to sending the packet to the hello packets to this particular routers. So suppose this particular router is not going to responding within 40 seconds, default 40 seconds. So this router assume that this peer is dead. So it will not going to send any information to this particular routers, and it will be communicate with each routers that this peer is going to be dead. So their topology tables, your routing tables, database tables should be updated same time. Then we have some designated routers. What does it mean? So one per multi-access networks generates networks link advertisements LSs type 2. All routers are adjacencies to it. Assist in DB synchronizations elected by the priority. It's elected by the highest router ID. So once you're going for the interview or anywhere, they will going to ask you the question regarding that how in the Ospf environment, how the designated router is going to be elected. So one per multi-access networks, this is one designated router will be there. As all routers are from the adjacent to it, and assist in database synchronizations. So if we just talking about here, if there is no adjacencies without DR distribution, there is no distribution router is over there. So all the routers are going to communicate to each other all the time, all the informations. There's nothing like that. Okay, this is more complex informations. It will take lots of time, memory utilization, CPU utilization, every changes. But adjacencies with the DR, if a designated router will be there, so it will going to communicate with each other that yes, the router is this peer is dead, this peer is working, this peer is some different IP addresses. Then how is the database going to be synchronization? Hello. Yes. Yes. Yeah. 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 Please. Oh, okay. So as compared to the different protocols, Oscar, this OSPF is looks like little simple. It's not complex as per this MPLS or BGP. You need to understand the working, the things like that, how it's gonna working. You need to understand the most important things into this, the topology, how the topology is going to be working. What are different routing protocols going to be working, and what are different databases going to be connecting, how the designated router is going to be working, how the what type of different LSAs, loud link state synchronizations LS is going to be create. Okay, and you need to check it out whether this is the same OSPF area or not, which area, which router ID it is belongs to, which interface going to connect which particular interfaces, which different routers. So the matter of fact that in the troubleshooting approach, once you're going for the OSPFs, so it is, if you have good understanding, sound knowledge about the OSPF, like the LSAs, like different routing tables, informations, databases, topologies. So it's very easy for you to troubleshoot in the Ospf environment. However, I will going to provide some different troubleshooting approaches in the Ospf. Okay, once we have done this one. So this is crucial to ensure correct and loop-free routing. So the database in synchronization, it means that why the database is going to be synchronization between the different routers. So what I'm trying to tell you here, suppose this router, this is a designated router, this the router, this four routers are there. Any changes into this particular router. So same times how this different routers came to know that there may be some changes. So this particular router, any changes, every 10 seconds the hello packets will be sending. This hello packets, it means that this link is active. Any changes into the database of this particular router, it will going to communicate with this particular designated routers. And the designated routers is going to send the particular configurations to the different routers same time. So crucial to ensure correct and loop-free routing. First thing, must be done before two neighbors start communications. So database synchronization, it is two neighbors going to start the communications. So whenever new LSAs are introduced, use reliable flooding. Each router sends LSAs headers, small LSA to its neighbor when connections comes up. So the matter of fact that the LSA is different type of LSAs. So different type of messages will be going to pass into the different routers as per the communications, as per the changes, as per the modifications. So request only those LSAs which are recent. So the database synchronization, it is basically that databases will be synchronized between the two different routers, loop free routing. Okay, we're talking about reliable flooding. So starts when a router wants to update self-organization LSAs. So what happened in the reliable starts when the router wants to update self-originated LSAs, because routers are going to create LSAs for ourselves as well, and they were going to sending to different routers. So neighbor installs more recent LSAs into its databases. So the LSAs, is very important to understand here that your neighbors going to install more recent LSAs. If your LSAs are not recent, the old informations will be there. Then there is no use of it, my dear friends. It will not going to be synchronized. It will take to the synchronize, and then there is a possibility that the not loop free environment will going to create. So floods out all the interfaces except the one on which it arrived. So the reliability, the transmissions until asks received. So the reliable flooding is basically talking about we have some subnet available 10.1.1.1, 2, 3, 4, 5, and 6. So this is the any changes will be there. So these are the two interfaces. This one, and this one. It is going to be update all three interfaces same time, sending an update to all the interfaces, flooding. So recent updates going to be updated in this particular database or this particular different routers. So it's a bi-directional. Okay, different direction. It is going to be connected the interfaces. And once in the every 10 seconds, this particular router is going to send an update. So it is checks that yes, there may be some changes in my topology, in my routing. So it is going to synchronize with your database with the different routers same time. Then once this router is going to be, information will be available, then it is going to update with this particular routers 10.1.4 and 10.1.16. So the reliable flooding will be there. So once the information will be coming here, it is going to sending this one, and this is only one interface connected. It will going to sync with this particular things. So it will going to so it will going to update all the routers same times. Reliable flooding. The communications, okay, this database will be synchronized with each of the routers same time. The same things will be there. So once it is going to come, then they will going to provide the acknowledgement. So every router is going to acknowledgement, yes, we have updated our databases. So another thing is comes to the pictures, routing calculations. So link cost configurable by administrator. So if you are going to do a static routing, then the administrator is going to provide a costing, link costs. So the smaller values for the more preferred links. So there are specific values for the particular links. Suppose 100 Mbps, there is some values. It's a 1 gigabit link, there is some value. And different cost for each link direction possibilities possible. So Dijkstra shortest path algorithms. So if you're talking about into the Ospf, the Ospf is going to take a shortest path first on the Dijkstra patterns. So incrementally calculates tree of shortest paths. Each link in the network examined once and computes multiple shortest paths, equal cost path, multipath. So the matter of fact that in the routing configurations, routing decisions. So once we're talking about the BGP routing decisions, we're talking about some MPLS routing decisions. We're talking about some OSPF routing decisions. How the routing calculations is going to be working in the OSPF environment. So all routing protocols have different scenarios of routing calculations. In the BGP environment, IBGP environment, EBGP environment, and they will going to check it out the cost and then they will going to send the packets. So the matter of fact that if you're going to use the OSPF, so the value is 110, and it is going to use a Dijkstra shortest path for algorithms. So it is a matter of fact that in this particular slide, what type of link you're going to use it. Suppose this link, this particular router is this link is 100 Mbps link is. This is 1 gigabit, 1 gig link is this. This is 10 gig link is this. Smaller values of more than preferred links. Different cost for the each link direction possible. So matter of fact that what type of configurations has been configured by the network administrator. So different values for different links. Suppose you are going to use the 100 Mbps link, there is a specific values. I'm not remember right now. I cannot. That's why. What is the values? So different values will be there. So each link in the network examined once. Okay. Suppose this router, this is a router, and this is going to send any informations. Then it will going to check it out. This one, this path, this path or the third one. So which is the right path, shortest path first, SPF, and this is going to be calculated as per this particular things, routing. So it will going to check it out the link cost. It will going to check it out a different cost link direction, which direction it is going to send. It will going to check it out the discussed shortest path algorithms. So the matter of fact that it is going to be changed as per the required. So this is the particular Ospf areas. So two-level hierarchical routing scheme through the use of the areas. Areas identified by 32-bit ID. Each area has its own linked state database, which is collection of networks, LSEs and router LSEs. Areas topology hidden from all other areas. All areas connected through backbone area 0. Interconnection of the areas through area border routers ABR. Area border router leaks IP addressing information to other areas through some of the LSAs. So this is a sample thing is there. So this is the area 0 is your backbone area, and there is 1 and 2 and 3 routers will be available. Okay, so this routers 1, 2 and 3 routers are the IGP, interior gateway protocol. Okay, and this particular ASB are area border routers. This one and this one. So this particular ABR router, area border routers, have the information about this particular area 0 connections and also area 35. But if you're talking about this area 1 ID, this router and this router have the same subnet. Same topology will be, you find out. They are going to communicate with each other's specific 10 seconds hello packets, 40 seconds by default hello packets. So by default, if you going for the multicasting or this particular area like area 1, this router, so they are going to use 224.0.0.5, and this area border router is going to be used 224.0.0.6. So once this router is going to communicate with this routers, this is going to be every 10 seconds going to be send packets, updates, hello messages. And if these routers are not going to update within 40 seconds, it will send that it's a dead peer. So what happened at the same time, the LSAs will be going to be sent link state advertisement. The recent LSAs will be more reliable. So same sort of terminology will be working on the same area 35. So all the information about the area 35, this area border router have informations. And this particular area 0 is going to connect with the internet. So suppose this router is going to connect with a switch, and switch is connected to the users, and user is going to asking some queries like area 35. So it will going to send a packet to the ABR, and ABR going to provide information from the area 35. So before it will going to the ABR, it will going to check it out in the local IGP. What does it mean? Suppose there is some issue will be happen on the IGP environment, interior gateway protocol. So what you're going to do, you have to go for the show IP route command, show CDP neighbor details. You have to check it out the different prefixes. You have to check it out the costing. You have to check it out the register methods, how one are working. You need to check it out the interface speed. You need to check it out the interface and negotiation things. Okay, you will have to go for the shed and no shed command, going to use it for the interfaces. So these sort of things you need to be work on a particular IGB environment. So the reduction in the link state databases of an area. So the reduction on the amount of flooding traffic needed for synchronizations. The reduction in the cost of the shortest path calculations. Increased robustness, routing protections, hidden prefixes. So why are we going to use the Ospf areas? If you have more than 100, more 200, 300 number of routers will be there. Suppose this one. Suppose in your area their number of firewalls is 200, 300. So it will take lots of time to synchronize with all the informations like database tables, routing table, and topology tables sort of things in all the IGP environment. So we have to segregate the networks into different areas. So if we're going to subdivide it into the different areas, so this is all the 5 to 10 or 25 routers are going to exchange the information to each other. So it is very fast. Increased robustness, routing protection, hidden prefixes, that reduction in the cost of shortest path calculations, addition in the link state database of an area. So the matter of fact that, my dear friend, in the OSPF areas, OSPF LSAs, OSPF 3 tables, OSPF routing decision making, this is all you need to be studied, need to be learned, which I am talking right now. So incorporating external routing informations. So the special routers called as autonomous system boundary routers at the edge of the OSPF domain. ASBR organized AS external LSAs. Only routers for which the choice of an ASBR makes sense are imported. Otherwise, default routes are used. So the matter of fact that the default routes are going to be used if you not define the path, correct path. Inter-area communications LSA1 and LSA2. Router LSAs, all routers in the area and LSA type 2 network LSAs designated routers unit its. So inter-area and intra-area communications. So LSA type 3, LSS ABR LSAs, and LSA type 5 is summary ASBR LSAs. So restrict the amount of external routing informations with an area used when resources, especially routing memory, is very limited. So when types of restricted areas is stub areas and other not covered on this training. So we have different areas will be implemented into the OSPF environment. So the stub area, it's not so stub areas. So don't support ASBR and hence the external autonomous systems external LSAs will be there. Routing to external destinations based on the default routes, organizing areas border routers. Summary LSAs also made optional. Must lie on the edge of the OSPF routing domain. Inter-area routing may also be based on the default routes, improved scaling, but not preferred due to the possibility of sub-optional routes. So stubs area are not supporting the ASPR, first things, and no external LSs will be there. This is the routing commands. We're going to use it into the different routers. Configure router. This is the small commands for the Cisco platforms. You're going to use it. So there's the Ospf verifications command you need to be understand. This is very important. So IP Ospf neighbors. Show IP Ospf interfaces. Show IP Ospf database. Show IP root and show IP interface brief. So these are the commands you're going to use it for troubleshooting any issues. Issues not covered: Ospf area types NSA not so stubby area, totally stubby area, totally not so stubby area, Ospf network types, broadcast subnets, NBMA subnets, Ospf in the WAN, Ospf management, virtual links, Ospf NIB16, and many other instances there. So Oscars, we have understanding all the conceptual and the logical things of the Ospf. So what we're going to do it, I will going to provide you some assignments for BGP, MPLS, and Ospf. So what you're going to do it, you need to get all the advanced knowledge about the Ospf, MPLS, and BGP, the troubleshooting approach, everything. How are you going to troubleshoot? What are the use case scenarios in current industry, in the modern time? What are different issues will be coming, and how are you going to be troubleshooting? So what I'm going to do it, I'm just going to providing some case scenarios. So you will have to provide the answers, what to do at what circumstances will be coming. Okay, and also I'm able to download all this particular file of the Jncis environment. Okay, this is 5.13 GB engine size. So I'm just going to this OVA file export into the virtual box. Okay, so that we will going to for some more practical things. In meanwhile, what you can do, you will have to be just doing the assignments. I will going to provide some informations, Ospf, MPLS, BGP, and same time we have two pending topics here is the multicasting. Okay, and we need to understand the RIP and EIGRP as well. So however, it is not going to be used, but you have basic understanding. This two protocols will be required. Am I right?
Yeah.
So okay, so what I'm going to do, we have all the concepts, the logic, the understanding, we have done it. So I'm just going to provide you some use case scenarios. So try to figure out, try to troubleshoot the issues, and I will help you out. I will gonna support you. What is the things you need to doing it in the MPLS, the BGP, and Ospf. These are the three protocols is very important, as well as we have also studied about the Juniper firewalls, security policies, and routing policies. Okay, the control plan and also the forwarding plans in the Junos environment. So I already forward you so many things. Just try to study for this weekend. So you will have to work on the weekends, and then Monday I will going to provide the answers, all sort of things. If you are not going to require any support and help into the same, am I right?
Okay.
And I will also going for your mock test. Mock test, it means that I will going to ask you some use case scenarios into the BGP, MPLS, and OSPF. You should providing me the answers. This is suppose these things will be happen. What to do? Suppose you have some issues. Suppose you are facing some issues in the BGP in the path attributes. So what to do to correct the informations? What to do? What so that we can going to troubleshoot the issues in the BGP. Okay. So I'm just gonna providing some assignments to you, and let's see what you can do. And in meanwhile, I'm just going to do some the labs environment sort of things. I'm going to try to set up. Perfect.
Okay.
Any questions you would like to ask to me? Anything you would not understand, or whatever? What's your thoughts about it? We're going as per the plan or not? Anything else you would like to share to me, sir? This is the things this is the requirement. This is what I'm expecting. ASBR for the internet. Can you show examples? Yeah, sure, sure. We will do it on the sim. So what you can do it, Oscar? Just you know what? Any doubts you have, just ping me on the Skype. I will going to provide specific answers on the all sort of things.
Okay.
Okay. So ASBR is one of them, or whatever you feel that yes, sir, this is the things I need to understand. So I will going to provide you some help into this.
Okay.
Okay, and also we are going as per the plan. So the assignments, the projects, the practical things, and the conceptual things, it's gonna working together so that you can understand each and every concepts.
Okay.
Okay, Oscar, anything else you would like to share to me?
That's it.
So whatever you doubts, you just write it down on the Skype, or just note down in the notepad and send to me so that I will gonna be help you out. This is things you gonna be use it. If these things will be available, what you going to do it?
Okay.
Okay, makes sense.
Yes.
Yeah, thank you for your time, and I will provide you some assignments. Then we will go for some more things. So take care, enjoy.
Right. Bye bye.
Okay.